about transformations in a very broad sense, okay? We've put everything under the umbrella term of transformations, which it's true, it is. But there are, y'all please stop talking, okay? Okay? There are actually 3 separate types of transformations that we've been dealing with. So we can have a translation of a function, which moves the graph or shifts the graph left, right, up, down, okay? You can also have and translations do not change the shape of the graph, okay? All translation do is move the graph. So nothing changes. It's just like picking the graph up and moving it somewhere else, okay? Then we also have a dilation. Y'all please stop your extra conversations, okay? So, and a dilation causes our graph to stretch or compress, okay? So those are the ones that actually change the shape of our graph. They change what the graph looks like. They make it taller, skinnier, wider, flatter. They do something to the graph. They change what it looks like. And then we also have a reflection, which all a reflection does is it flips the graph. We're specifically been talking about a reflection across the x-axis, okay? So that is a vertical reflection. We can also have reflections across the y-axis and things like that, but that's not really something we've been looking at because a lot of our graphs have been symmetric, so it doesn't affect anything. Now, we're going to go ahead and we are going to go through all of our different transformations and make sure we remember the rules for our transformations and how those transformations affect parent functions. So our full transformation rules are right here, and we're going to look at each piece of them. So we're going to start with translations. So if we have plus h inside of our function, how does that affect our graph? To the left h units. Okay, what about if we have minus h inside our function? To the right h units. Where's your paper? Yeah, get it out, please, and thank you. All right, what about the plus k? If it's outside the function, how does that affect our graph? It will go up k units. Okay, what about a minus k outside of our function? So those are the ways that our graph can be shifted, left, right, up, or down. Okay, now we're going to look at dilations and recap those real quick. So these are where we are multiplying our function by some number a. Okay, so if a is greater than 1, what does that do to our graph? It is a stretch. Yeah. So we're going to say a vertical stretch. Sometimes you may even see it written as like it's being expanded vertically, but that's still a vertical stretch. Okay. We can also have our a be between 0 and 1. What does that cause? Vertical shrink. What's the other way I could write that? You can call it a shrink or a compression. So those are our dilations. Those are the things that do change the shape of our graph. Okay? They make our graph taller, skinnier, shorter, flatter. They change something about the dimensions of our function. Okay? What about this minus in the very, very front? What does that cause to happen? Specifically, it's a reflection across the x-axis. So that is our transformation rules. These are not new. We've used them several times at this point, okay? So what we're going to do is we're going to go through some examples with using the transformation rules, okay? Then we'll go with some examples of writing functions from our transformation rules, and then we're practicing, okay? So this first section down here is just identifying transformations. So we just have to describe how the following functions compare to their parent functions. The parent functions we're going to look at specifically are our absolute value function, our quadratic function, and our square root function, okay? So the reason it's important to be able to kind of recognize what the parent function is because it kind of tells us what we're looking for and where the inside of the equation is. Like, where's the inside of the function? So if we look at number 1, here we have our absolute value function. We know that because we see our absolute value bars. Those act as our parentheses in this case, right? What is inside of the function is what's inside of those absolute value bars. So in this case, what is inside of our function? What does that plus 3 cause? To the left 3. Okay? Then outside of our function, we have plus 3. What is that? So that is our transformations for this one. Okay? And we're going to just go through the odds real quick, and then y'all can do the evens, and then we'll go over them. For number 3, okay? Number 3 is a good example of our quadratic function. So whatever is being squared, that will be the inside function. It'll be the inside part of our function. So in this one here, we have this negative at the very, very front. What does that cause to happen? Across the? Mm-hmm. And what about that 3 next to it? What does that cause to happen? It is a vertical stretch. Specifically, it would be a vertical stretch by a factor of 3. That minus 2, is that inside or outside of our function? Inside. So what does that cause? Goes to the right 2. And then at the end of our function there, we have minus 2. What does that cause? It is down 2. Okay? That is as complicated as one of these can get. Okay? It can only have 2 translations, 1 dilation, and 1 reflection. Okay? That is the max that we're going to have on one of these questions. This is about as hard as it gets. Okay? Number 5. This one is our square root function. So the inside of this function would be what is underneath the square root. Okay? So if we start at the beginning of this, what does that minus at the very, very front cause? It causes it to reflect across the x-axis. What about that 1/2? What does that cause? Vertical shrink. Or vertical compression. Is there any other transformations this one has? No. All right, so we have one last one we're going to go over together, and then I'm going to let y'all do the evens. So for number 7, which parent function do we have here? We have those absolute value bars, so it tells us we have the absolute value. So inside of the function is what is inside of those bars. So what does that 4 at the very front cause? Vertical stretch. What about the plus 3? What does that cause? Left 3, because it is inside of our function. Then last but not least, what does the minus 7 do? Down 7, because it is outside of our function. All right, I want y'all to go ahead and do the evens right there next to that. All right. So I want us to real quickly go over these evens. Okay. What is the transformations on number 2? Vertical stretch and down 5. Okay. For number 4, what are our transformations? Yep, vertical shrink by a factor of 2/3 and down 3. Okay. For number 6, okay. Here is a great example of what it looks like if it is inside the square root function. It means it's going to be inside that radical too. So what's happening inside of our square root function there? Left 5. That plus 5 sends it to the left. What about the minus 2? For number 7, what transformations happen for number 7? A reflection across the x-axis. Yep. Right 5? Up 1. Okay, so those are our transformations. So now we're going to go ahead and talk about how to write our functions given the transformations. Okay, we've done this a little bit. We did it a lot with quadratics. Okay, but we're going to do it with all the different kinds of functions that we have up here. So the fun thing about transformations is they stay the same regardless of what type of function you have. If you're using any of our parent functions, you identify transformations the exact same way using the exact same rules. And you can use them for any of them. Now, in Algebra 1, you don't talk about every single type of parent function. We just talk about some of them, okay? But as we go through this and as you go through different math classes, these transformation rules stay the same, so we can use them pretty much whenever. So back here, boys, stop. Okay, so back here we have our writing function section. So we are going to look at the transformations of parent functions. We're going to again have our absolute value function, our quadratic function, and our square root function. And we are going to write the equation of the new function given the transformations. So we're going to look at number 9. And we're going to go through our odds again. So for number 9, we have our absolute value function, and we're going to translate it 6 units to the right. So whenever we have one of these, the best way to start, regardless of what the function is to start by just writing out your parent function and leave you some gaps in there so that you can just fill in if you need to, okay, wherever it goes. So this one, we are just translating 6 units right. So to go 6 units to the right, what do I do? Minus 6 where? Inside of our function. And so that is what we write. It's f of x is equal to the absolute value of x minus 6. All right, for number 11, we have a vertical stretch of g of x is equal to x squared. So that's our absolute value function as our quadratic. So we're going to go ahead and set up g of x is equal to x squared. And I'm going to leave me room to write in there if I have some transformations. Okay, by setting it up like that first, it lets you do the exact same first step every single time and then just apply the rules and not have to do it as you go. Okay, so vertically stretch by a factor of 5. What does that tell us we need to do? 5 where? In the very front. Okay. And then it's saying it's going to the left 1 unit. What do I need to do for the left 1 unit? Plus 1 where? Inside of the function. So we have 5 times x plus 1 squared. Okay. Parentheses are an awesome tool for this to make sure it's very clear where things are inside or outside of our function. Okay. Number 13. So for number 13, we have our parent function is our square root function. So we're going to just start by setting it up. We're going to do h of x is equal to the square root of x. Okay, then we're going to figure out all what's happening. We have a vertical compression by a factor of 2/3. So what do I need to do with that 2/3? Put it in the front. Okay, we then have reflection across the x-axis. How do I do that? Where do I need to put the negative? In front of the 2/3. So we get negative 2/3 times the square root of x. All right, so I want y'all to go give the evens a try for me real quick. Yes. Yes. All right. What did y'all do for number 10? What's the equation for number 10? Absolute value of x plus 2. Okay, is there anything inside our function for this one? No. Okay, what about for number 11? So we do the x minus 3 squared minus 4. Okay, and we have to put the parentheses there to make sure we know that whole thing's being squared. Okay, number 14. Yep, h of x. So with this one, whenever we set this one up, ooh, that's the wrong button. All right, so what did y'all say we did with the 2? That goes in the very front. And then where does the right 4 need to go? Inside. When you do something inside of the square root, it has to make sure it's under the radical. Okay, so it'd be minus 4. You could also, if you wanted to, put that in parentheses. That's not a required thing for that, but it can help you to make sure it's very clear where your square root stops. And then what's the last piece of that? Okay, when you are putting something outside of the square root at the end, make sure you're not writing it up under the edge of the square root, because that, it's clear it's outside, but if you make that line a little too long, well, now what does it look like? It looks like it's inside, okay? So you have to be very careful where you put that outside transformation. Does that make sense? All right, so the only other type of function that we're going to be using really for this is the cubic function. Y'all don't have to write this, okay, but I'm going to do an example real quick. If I take the cubic function, so let's do f of x is equal to x cubed. So it's the same thing as squared, except it's being raised to the power of 3. Okay, and I want to have a vertical shrink by a factor of 1/2. How would I do that? Put 1/2 in the front. Okay, then it's going to be reflected across the x-axis. Put a negative in front. If I want to go left 3, what do I do? Where? And then down 7. Okay, so it doesn't matter what the function is that we're using. That same thing applies. Okay, so we're going to do some practice with this today. I'm going to pass out a green sheet, and we're going to do 12 questions. 6 of them are identifying transformations. 6 of them are writing the equations. And you will, if you haven't finished your blue sheet from yesterday, that also needs finished and turned in. We're going to turn in both of our assignments. Okay,